Hi, good morning. Today I'm going to be trying an experiment. If you notice, I'll be videotaping my lecture. I won't get the slide because obviously I don't have a camera person, and I don't expect any of you to do that because you should be paying attention to me and taking good notes. Now, what I will be doing is, because of the camera setup, I'll just be using this board, and nothing personal about the people on that side. We first moved into this building. That cabinet was there, so that board wasn't there. So I'm used to using this board. I'm not sure of the exact timing of it, but by the end of the week, I hope you'll be able to access these through Blackboard. So one thing I shall remind you, that is, I still will enforce, if you miss so many days, I reserve to write, I think it's 6 in the syllabus or 8, I forgot which I put down this semester. I reserve the right to give you an F, so just because they're going to be online doesn't mean you should miss class. And like I said, we're still working out some of the bugs. I'm working with media services here to get it, so you will be able to access it. We'll see how it works. Be a new experience. I think I'm the first one here who's going to post all the lectures like I'm doing. It's an experiment I've wanted to do for a while, and I finally was able to pull it off and get that through the help of many people here. And I will admit it will not be Hollywood style. It more looks like your own movies, but I think it's something that will help. All right. I've got that out of the way. Let's get back to organic chemistry, especially after that Super Bowl yesterday. Whoa. I still can't believe what my eyes saw. All right. Last week I promised I would go through the practice problems for alkanes, and Dr. White keeps his promise, so I better do that. All right, listen up. This is the first time we've done practice problems. What I do is I do one page at a time, and I should warn you, other than the Super Bowl miracle last night, unless you're an Atlanta fan, and it wasn't a miracle, my hearing hasn't changed. One of the hardest things for me to hear in a classroom is the letter of the alphabet. Now, I'm not deaf. I had one student to hear him out the building. And I said, no, you don't have to do it that loud, but when you say a letter of the alphabet, let me know and say it clearly. So please be patient if I ask you to repeat it once or twice. All right, again, one page at a time. And as always, there's no such thing as a dumb question. All right, page 1. Simple skill you should have. How many carbons are in the longest chain of the following? Any questions on these? Can you do D? Of course I can. They didn't warn you about what I do for problem sets. All right, question is, what's the longest chain? Well, you start counting, going across 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. One more I didn't put down there, 1, 2, 3, 4, 5. And I hope you all know 6 is the largest number, and therefore the longest chain would be 6. E and F. Anybody have questions about E or F? You do F? Of course I can. Stop that, just do one. I'm going to try and do at least 1 or 2 from each set. Question?
I actually do have a question on F. Okay, so...
Let's do it, and then you'll see if it answers your question. Question is, what's the longest chain? Remember, a bicycle chain or a chain around your neck like this can bend in many ways, but it's still connected together. So if we look at this, 1, 2, 3, 4, 5, 6. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Because this is connected to this, and so on. Finally, one other, 1, 2, 3, 4, 5, 6, 7, 8. And if I remember correctly, which I think I did, the largest one was 9. Does that answer your question?
Yeah, you can answer.
Again, it doesn't have to be straight across. A lot of times, usually you do that, except on tests, mine and the ACS. A little, I don't know if you call it a trick, but to see if you can determine what's the longest chain. All right. Next one. Give the IUPAC name for the following. Remember, I'll never ask on a test, but I like to say, because I think it's cool, IUPAC stands for International Union Pure Applied Chemistry. Well, when you see it like that, that means the official name. So the question is, what's the official name? Well, the first thing you have to do is find the longest chain of each of the molecules. And if we look at, let's do this one, C. 1, 2, 3, 4, 5, 6, 7, 8, 9. Hopefully you've learned your table on alkanes. 9 is no name. Now I showed it this way where you can use parentheses because they're repeating CH2s. On my test, I will not do that until we get to test number 4. And therefore you'll see it this way. All right, D, E, F, or G. Any of those you'd like me to do? Which one?
G.
All right, let's do it, and then we'll see. And once in a while, I make a mistake on these, so let's make sure if I do. All right, first thing you have to do is find the longest chain. And this one, 1, 2, 3, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. So the longest chain is 9, if I remember correctly, straight across. No name. As soon as I say that, what's left? These two alkyl groups. 1 carbon is methyl. 3 carbons is propyl. There are 2 propyls, N-propyl and isopropyl. When the 3-carbon alkyl group is connected to the center carbon, that's isopropyl. So we have methyl isopropyl. If you put the isopropyl first, don't tell the IUPAC, please. I'm recording it. But anyways, don't tell anybody, but I'll accept it on the test. IUPAC, it's wrong. Next, which carbons are they on? You start only from the ends. Common mistake on test number 1. So don't make this. Students say, I'll start here. No, you can only start numbering from the ends. 1, 2, 3, 4. If I start from this end, 1, 2, 3, 4, 5, 6, 7, 8. This going this way would be 6, 8. Going this way, 2, 4. You go from the side that gives you the lowest numbers. Therefore, the methyl group is on 2. The isopropyl is on 4. Am I good or am I good? Don't answer that. And that's the question.
So you have this as alphabetical order then, right?
Right. If you had put on a test, all right, here's the problem, which is why I don't hold you to the IUPAC. If you look at the slide I had, and if you go online to IUPAC, they have the rules too, or you go to Wikipedia, they have a condensed version like mine. When you look at an alkyl group, the prefix iso is ignored. So this is an M, this is a P. And that's why this would come first. However, in my class on the test, if you had written 4 isopropyl 2 methyl, I would give you full credit, and you have everybody around you as witness I said that. Okay?
Okay, yeah, because I did, so for F, I switched them, methyl and F.
But I would consider, because E comes before M, that's why you put the ethyl first. But if you put it 2 methyl 4 ethyl, I would have given you full credit. Ooh, a ring. How do you do a ring? Count the number of bends. How many are there? 1, 2, 3, 4, 5, 6. That's hexane. Common mistake on test number 1. So don't make it, please. You forget, it's a ring, it's cyclopentane. So you put the prefix cyclo for a ring in front of the number of carbons. So it's cyclohexane. All right, I, J, or K. Any ones on those? You do K? Of course I can. Let's do it. Question is, what's the IUPAC name? And here, what do? you always look at what's different. Oh, I don't have a chain, but I got a ring. How many carbons that ring? Count the bends. 1, 2, 3, 4, 5. Pentane, it's a ring, cyclopentane. We have here an ethyl group and a T-butyl group. The alkyl group with the highest alphabetical priority, 1 at the front, gets the lowest number. So this is 1, you go either clockwise or counterclockwise to give all the alkyl groups the lowest number. So this is 1, this would be 2. If you went the other way, 1, 2, 3, 4, 5. I hope you all agree 2 is smaller than 5. That's some of the hard math you have to know from my class. And therefore, this would be 1 tert-butyl, 2 ethyl cyclopentane. But since on a ring I told you wouldn't count that, I hold you to it, there are actually 3 other answers. This is the correct IUPAC, but 3 other ones would be put the ethyl first and then the T-butyl second, and then swap the numbers, and you could have 2 tert-butyl, 1 ethyl, I would accept that, and you could put the 1 ethyl first and the 2 tert-butyl second. But if you get the base name wrong, cyclopentane, I'll never give partial credit on the test. Does that answer your question?
Yeah. Okay, so between like I and K, when you have just the 1, which is the isopropyl cyclohexane,
When you
You
have
don't
one
have to-
alkyl group on a ring,
you don't have to put a
you don't
number.
put a number because every carbon is 1. If I were to put it like this, I promise I use this board. And that would be isopropyl group. Would that be different than that? And the answer is no. It's like, here is my hand, here is my hand. Oh, is that something different? No, you just rotated it. And as you learned, everybody last week, rings exist in 3D like this pen, and you can move them around. And therefore, since that and that are the same, you can't say, is that 2, is that 3, is that 1, is that 2? No number, because every carbon, when there's one alkyl group, no matter which carbon, is number 1. All right, the other nomenclature, remember nomenclature is a fancy way of saying the name. Nomenclature skill you should have, hint, and that is draw the condensed structures for the following IUPAC names of the molecules. Butane, you should know that's 4 carbons. Ooh, I haven't done this in a while. You haven't done this in a while. Class, how many bonds to carbon?
4.
Thank you. Remember that. That will help you on test number 1, 2, 3, 4, 5, and the final. All right, so butane, 4 carbons. All right, I have C, D, E, or F. Does anybody have one on which one goes? Yes, please.
How do you know when to put dashes between?
All right, dashes go between numbers and letters, commas go between numbers. If you forget a dash, I'll smile, I'll put it down there with my red pen, and I will not take off points. If you forget a comma, then I will take off, because if it's 2, 3, you actually have 23, which can't be right.
Because like for like butane, for instance, number or the
Once in
B.
a while, I forget to, there should be a dash right here. Hold on. Bad Dr. White.
Like for B, you just put CH3, CH2, CH2, CH3.
Oh, you mean in the structures?
Yeah, but
That,
then
you actually, technically, you don't put those in there. I do it to keep it straight. So if you use them or don't on the test, doesn't bother me.
okay.
My software usually doesn't. Let's find out. Well, I actually, like here, if you look here, this one I had to do myself. This one is from the software. Notice there's no dash between the 2 carbons. Either way, as long as I can make out what it is and it looks right, I'm going to give you credit. When I grade a test, I'm not sitting there and saying, oh, how many points can I take off that student's test? I grade it and say, I hope this is right, and I do. All right, while we're in the neighborhood, let's do F. And what is F? Well, it's missing a dash, but pretend it's there. It really should be this. I said I wouldn't use this board. Well, I'll try not to. And notice when you start decoding this, you go this direction. Hexane, 6 carbons. So I have a chain with 6 carbons, 2, 4, 6. And then methyl, CH3, di, 2. And what carbons are they on? Carbons 2 and 3. This would be 1, 2, 3. You could have started here, 1, 2, 3, and they'd be on those 2 carbons, and that's how you do it. Here I actually made a mistake in the nomenclature, this whole name, and that should be 1-tert-butyl 2-ethyl cyclopentane. But any questions on G, H, or I?
Why isn't it the other way?
Which way? This is
For
wrong.
I, yeah, why?
Let me do it correctly. Well, drawing the name I should have done. Once in a while, I'll even make mistakes. Like I said, the first day of class, I don't walk on water unless it's frozen. Even then, I stay off. All right, let me write it correctly. And here's the name. The question is how is the right way. I should have done it. I tried to correct it there. I was just lazy. Anyways, how do you decode this? You start from the right. Pentane, 5 carbons. Cyclo, 5 carbons in a ring. And then on carbon 2 is an ethyl. Carbon 1 is a T-butyl. Now, you can pick any one of these and call it carbon 1. I happen to call it this way. You could have called it this way. And if that's carbon 1, and carbon 2 is an ethyl, which could be that carbon, and that, or that carbon. Since most of you will go this way, I'll do this. And this are the same thing. This is just flipped 180 degrees. Luckily, I know how to interpret that it's right, so that's how you do it. Does that answer your question?
No.
What was your question?
Okay, so when I first started looking at this, I put CH2, CH3 first.
All right, well,
And counted
again,
that as one.
either way, you're going to get the same thing, because 1 is on the next carbon next to the other one.
Okay, so if the numbers are switched, it would still,
Does still be the same.
okay.
Again, the names are such so they're relative. All right. Did everybody get K? Propane? Remember what I wrote on the first day of class? I bet most of you will even be able to remember what color ink I use. All right, next question. There's going to be 3 types of questions on my test. First one I call general knowledge. Second one, nomenclature. 2 types of nomenclature. Actually 3 for this test. What's the longest chain, which you should know how to do. Here's the structure, give the name. Here's the name, give the structure. Another major area is give the product or products for the following. And for alkanes, it's very straightforward. There's only one reaction I can ask about. And here it is, give the product or products for the following. And let's pick one. Oh, let's do B. B, what do we have? And let me put it on the board. And in case you didn't remember, that's octane, which good part of the weight of gasoline that you buy for your car or so other people buy for their cars is octane and isomers of octane. React it with oxygen with a little spark. You have combustion. What's the general reaction? take an alkane or cycloalkane, react it with oxygen, what do you get? This part you have to know. Well, you don't have to, but you'll miss the 3 points if this were on the test. And you say, oh, that's octane, it's an alkane, reacted with oxygen, I get CO2 and water, therefore the answer here is CO2 and water. And that's how you do it. Do you have to write that down underneath on the test? No, but some of my best students do, and some of my best students don't. That's up to you, but you should have it recorded somewhere. I think it's right back here. And that's how you do it, other than record it right over there. And all those have the same answer. Any questions on the alkanes problem set? Going once? Going twice? All right, listen carefully. Hopefully you tried this on your own. If not, I'd highly recommend you try it on your own. You'll see right after test number 1 why I call these practice problems. Question?
How many questions are going to be on the first test?
I haven't finished that. Probably by Thursday, I'll have that posted online. I'll talk about it in class. So I think the first test is a week from this Thursday. But one thing I shall tell you, and I always have and always will, if you've practiced the material, do the practice problems, and can do them correctly, my test should take about 35, 40 minutes. You'll have 50, 55 minutes to do it, but most students are done within about 40 minutes. I don't write a test so the smartest, fastest person is the only one that finishes, because that violates my golden rule of teaching. Don't do unto my students what I didn't like done to me. Usually I was the fastest in the first, but there's no reward for that on my test. You'll have plenty of time. And also on my test, every question on my test, I'll cover the concept behind that question at least twice. Ooh, 4 months of garbage. Couldn't pass that one, huh? All right, last week I was talking about the chemistry of double bonds. We went through hydration. I taught you about Markovnikov's law, or rule. The rich get richer, the poor get poorer. How you deal with unsymmetrical addition to double bond. And now let's continue on. And the other part of this chapter that I'd like to talk about alkynes. Alkynes are triple bonds. They're similar to double bonds, but not really, because you have not 2 bonds between carbons, you have 3. How do you tell that? 3 lines. And that's an alkyne. How do you name them? Well, I've gone back to earlier slides, and I also have for alkynes. What you do is find the longest chain with both carbons of double bond. And if we look at this molecule, I've been training you, and it's a good thing because I do the same thing. When you look at a molecule, look for something that's different. What's not a carbon-carbon single bond, what's not a carbon or hydrogen atom, and that should get your attention like that. Oh, it's working today. And triple bond, how do you name it? You find the longest chain that has both carbons of the triple bond. In this case, 1, 2, 3, 4, 5, 6. Hexane. You drop the A-N-E ending. I did. And you put in Y-N-E. Y-N-E ending, it denotes triple bond. Now, am I done? No. You need to put down what's the number of the lead or lowest carbon of the triple bond, and you number from the side that gives the 2 carbons the lowest numbers, and of those 2 you pick that lowest number, which is 2. If I went the other side, it'd be 1, 2, 3, 4, 5. I hope you all agree 2 is smaller than 4. So now I have 2 hexyne. Now, the bond angle of a triple bond and this I'll never ask on a test, but it's 180 degrees. Therefore, you can't have cis or trans. We're done. It's impossible in a triple bond. Now, the alkyl groups you handle the same way you've handled the alkyl groups before. And I should point out, as I'm erasing it, that this counts as 3 bonds to each carbon. And one other thing, my software and I do it, on the N carbon of the triple bond, you can left justify this hydrogen or put it like this. So it can go on either side. And I would ask you, because you know Dr. White's going to share, what's the IUPAC name for the following? Remember, triple bond, Y-N-E ending. Got some questions?
I'm just a little confused.
I'll do another one. Let's try this one and but you find the longest chain with double bond, name it as alkane, drop the A-N-E ending, put Y-N-E, number of words, double bond, and the alkyl group.
I get that part. I don't get why there's an H before the first C.
What?
I understand that portion. I just don't understand why there's an H for
All right,
C
well,
before
let's-
C.
I mean, why are there no hydrogens? Or
Yes, the very first carbon, why is there a hydrogen behind it?
I mean, why is it on this side?
Yes.
It's just convention. You can put it on either side.
So it could be
It could be like this, or I could have just as easily written it like this.
Okay, all right, I get it now.
And I do both. I'm not consistent.
Okay. Thank you.
I'm being honest with you. Yeah, I think it's your side to start first. If not, I'll do yours tomorrow. All right, let's take a look at this. Question is, what's the IUPAC name for the following? What do? You look at it and say, what's different? Oh, a triple bond. That's different. How many carbons in the longest chain with both carbons of the triple bond? Don't know. 1, 2, 3, 4. 1, 2, 3, 4, 5. So hopefully all agree 5 is greater than 4. 5 carbons is pentane. You drop the A-N-E ending, because I have a triple bond, put Y-N-E. Next, which carbon is the lead carbon of triple bond? 1, 2, 3, it would be 1 pentyne. Am I done?
No.
No, because you have, oh look, it's your old friend now, the methyl group, CH3. And what carbon is it on? 3, so that would be 3-methyl, 1 pentyne. And since I promised I'd do another one, let's do one. Remember, it's your solemn responsibility, make sure I don't make a mistake when I'm putting in hydrants. And the question would be, what's the IUPAC name for the following? Remember, when you're done, look up and smile. Does that work? It works for some of you. All right, let's take a look at this. And the first question you have to ask is there something different? And the answer is yes. Remember, different means not a carbon-carbon single bond or carbon-hydrogen, triple bond. I can't look anywhere else. When I actually, in real life, which this is, but when I'm not here in a classroom, if I'm looking at something where it has structures, any structure, I always look where are the functional groups, what's different. Triple bond, how many carbons in the longest chain? Don't know. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I hope you all agree it's 10. You don't count this carbon because you need both carbons of the double triple bond in the longest chain. So 10 is decane. You drop the ane ending, put yne, decyne. Next, what carbon is the lead carbon? And that would be 3, so it's 3 decyne. And finally, am I done? No, I need to pick me up, so I put down a T-butyl group because they make me happy, tert-butyl. And by next week, I'll be calling it T-butyl, which most organic chemists do. If you put either one on a test, it's fine. And then what carbon is it on? 5. So it's 5 tert-butyl, 3 decyne. And that's how you do triple bonds. Yes?
Will we ever see an instance?
What?
Will we ever see an instance where there's a substituent that would make the chain longer, but you have to count differently because of?
I try not to.
Okay.
As I had on the alkanes, just because it's not in the straight across doesn't mean it's not part of the longest chain. So if it's part of the longest chain, it's not really a substituent. So the answer to the question, I guess honestly, would be no, never. Because if it looks like it should be part of the chain, it's not really a substituent. But in other words, if you call it a methyl group, it's not part of the longest chain. Okay? Do what I taught you, find the longest chain, and one of the things, I can write a test where the best score in this class will be 20. You know what I just proved? I can trick everybody. My tests are designed, you show me you've learned the material. I try and be fair on it. All right, that's one skill with triple bonds, nomenclature, meaning naming. The other skill is, here's the name, draw the structure. And here, how do you decode the name to know what to draw? I'll give you a chance to catch up. By the way, catch up is organic chemistry. All right, let's take a look at the name. And the question is, draw the structure of the following. And what do? We start always from the right. And now, what do you look at? The ending. Y-N-E ending. Tells you you've got a triple bond. If that were A-N-E, that would be 10 carbons, decane. I have 10 carbons. Let me quick check. I do. And now Y-N-E tells me triple bond. What's the lead carbon? 2. So if I start here, 1, 2, I have my triple bond. And then I have on carbon 4 an N-propyl. Propyl 4, 3. N means it's attached to the N carbon. You could have put the CH2, CH3 on this side, and now, since I know, I tell you I'm ambidextrous, I can do this with either hand, there's 4 bonds to carbon, I can put in my hydrogens. And there's the structure. Let's go through it again. Start at the right, Y-N-E ending, triple bond. If that were A-N-E, decane, 10 carbons. I have 10 carbons. The triple bond starts at carbon 2. You could have started at the other chain end, but most of you are going to do it this way. The other end would have been correct also. And then on carbon 4 is N-propyl, 3 carbons to the N carbon, and that's how you do it. And why don't you try this one? Again, the question is, draw the structure for the following molecule. 4-methyl, 1-octane. I have a little something to tell you. We're all doing organic chemistry, and it's not that painful. I hope. Those who are quicker, please be patient. I try and give everybody time to finish. And it looks like the last hydrogen just went down. All right, how do you decode this? Know what to draw? You start from the right. Y-N-E ending, triple bond. If that were A-N-E, hopefully you've learned the table of the alkanes. Octane, 8 carbons. And let's see if I, 2, 4, 6, 8 carbons. Next, where is my triple bond? Starts at carbon 1. I'll call this one, you could have done the other side, 2, 3, 4, and carbon 4. I have a methyl group. I can put the hydrogen here or here. I'll put it there today. And there you go. Now, when it comes to triple bonds and rings, it's rare. I think in all the years I've been doing organic chemistry, many, many years ago, long ones, I can't even remember what decade, I saw an article, somebody did a publication where they made some monster rings with a triple bond in it. Not that it would ever be used in real life. When I say that, academic people sometimes do things that, oh, look what I can do. And a lot of times it's useful because later on, someone might say, I need to do that. Oh, someone's already done that. But all those years afterward, I've never seen anybody put a triple bond in a ring, because you need at least, and I'm going by memory, an old memory, I think that ring had at least 20 to 25 carbons, which is really, really, really rare. So we're not going to do rings. I'm done with nomenclature. Because the bond angle 180, it's impossible to have it in a 5 or 6 membered ring, which is what Mother Nature and Dr. White love. Oops, before I do this, I skipped this. All right, IUPAC was started in 1990, 1920. I'm not sure when their first book of rules came out, but it's new compared to how long people have been talking about organic molecules, like since the 1500s, 1600s, hundreds of years. So there were developed before IUPAC names, and a number of those names are still in use, and we call those common names. Now listen carefully. First of all, on the test, I will never ask you what's the common name of a structure, but I will ask you to draw the structure for this common name, because you'll see it on ingredients labels and you wonder, what's that? Now, the first two I won't ask you to learn, but they are words, names I'll use later. Ethylene is the simplest alkene, which you'd call ethene. Nobody calls it that. Use the common name. Then propylene is the simplest, next simplest alkene, and that would be propene. It would be one propene, even though you probably don't need a number because it's impossible to have 2 propene. That you don't need to know the structure. This you do. How it got the name acetylene, I have no idea. And did I spell it right? Yes, I did. And acetylene is the simplest alkyne, which would be ethyne, but the common name is acetylene. How many of you have ever seen in a movie or in real life, they have that super hot torches that can burn, melt metal? You see it in the movies, oh, let's cut the lock out of the safe. And they do that. Or in a metalworking shop, if they're cutting metal or heating it so you can loosen a bolt. And that's called an acetylene torch, because you burn oxygen with acetylene to give off a lot more heat than methane or propane will. A lot more. And you should know, if on the test, if I put down, draw the structure of acetylene, it's this compound. We'll learn later on, ethylene and propylene are used to make certain polymers, special big molecules. Polyethylene, you also know as saran wrap. So I told you, my world of organic chemistry is your world, you just don't know about it. Now, another one, this is on, the switch is off, on a test. You can have different types of substituents. You've learned alkyl groups. This is called alkenyl, because En double bond. And this is called a vinyl group. You will not ever see it on a test, but have you ever heard the thing vinyl covers or vinyl floors? And that's made with a molecule that has a vinyl group in it. And we'll talk more about vinyl when we get into polymers later in the semester. This will never be on my test. Sorry about jumping down, around, but. Real quick, I've already talked about, well, let me do it again. This won't be on the test, but alkynes, acyclic, meaning not in a ring, where you have a triple bond, the bond is linear, I showed you that. This I will ask you, and soon I'll put it on the board. They do the same reactions as alkenes, except you have 2 pi bonds, and the names are the same except you use the YNE ending instead of ENE for no cis trans isomers. All right, how am I doing on time? Doing good. When we talk about the chemistry of alkynes, triple bonds, what you need to know, switch is now on. Will this be on a test? Triple bond, not 1, but 2 pi bonds and 1 sigma bond. And you know what you can do with pi bonds, break them like that. And therefore the chemistry is, for many things, not all, but what I'll teach you is the same as double bonds, except you have 2 pi bonds. And the first reaction I like to talk about with a triple bond is hydrogenation. And remember, you have 2 pi bonds. When you learned in a double bond, you break a pi bond, each carbon gets a hydrogen. Well, if you have 2 pi bonds, each time you break a pi bond, each carbon gets a hydrogen, 2 pi bonds, each carbon gets 2 hydrogens. Now, organic chemists are lazy, I'll admit it, I am. We don't like to balance things. Well, if you got 2 pi bonds, you need more hydrogen. Should we balance this? No. We're going to use something that makes our life easy. Bracket, letters X and S, close bracket. That stands for excess. And that means I have all the hydrogen in the world that will react with anything hydrogen can react with. So now I have 2 pi bonds. I don't have to balance it because I have as many moles or amount of hydrogen as I'll ever need to react with that. And that's a triple bond, and that's how you do it. All right, quick commercial from the management, me. Lab this week. Those of you tomorrow and Thursday, don't forget to bring your lab in that you did last week and hand it in. You've already answered the questions. Also make sure your name's on there. For those who have lab tomorrow and Thursday, make sure you wear proper clothing and shoes. This week's lab, everybody's attention. You will need safety goggles or safety glasses. I believe the bookstore sells them, and there are other places you can buy them too. Don't forget to bring them, because if you're not wearing your safety goggles or glasses, I will not let you in the lab. With that, I'm going to end the whole 30 seconds early, and I will see you tomorrow.